Hello and welcome to Metra AV Tech Tips. I'm Brent.
I'm Adam.
Welcome aboard. Now today's going to be interesting because we're talking about a subject that I legitimately have no clues about.
Yep.
I mean, other than the fact I know this is what we use to do the job we're going to discuss.
Yep.
That's the extent of my knowledge, so promise me there's no math.
No math. Yeah.
Okay.
No math. Nope. Yeah, I made sure that today's episode, there is a lot of math involved with what we're talking about.
But you're not doing it.
I'm not doing any of it.
Okay, now
yeah.
hopefully I will be able to come up with one or two proper questions based on this because you did not take the opportunity to brief me beforehand, I think just to enjoy my ignorance and stupidity.
It's my favorite thing. Yeah, it's my absolute favorite thing.
Here's the thing. I believe you.
So, as always, everyone, if you have, we are here today to answer also tech questions as well as bring you good information and tech tips. But as always, if you have any questions about whatever it is that we are talking about, feel free to leave it over in the chat section over here or down in the comment section below. As always, share, and subscribe is always helpful. And don't forget to hit that bell notification to let you know whenever we do go live, which of course is every Wednesday at 3 p.m.
And Friday.
And Friday.
And occasionally earlier than we anticipate. On occasion.
Yeah, well, yeah. You'll be notified every time that we accidentally go live.
And it's always entertaining.
It's always entertaining.
Not always good for us, but always entertaining.
I got an idea. Every time that we accidentally go live, whoever calls us and lets us know that we accidentally went live first gets like a free shirt or something like that.
Okay. Particularly if they can repeat whatever it was we said, because
that's what needs to happen.
Can promise you whatever it was we said
we weren't supposed to say.
Been.
Yeah, exactly. So, okay, so
what
today,
are we talking about today?
That's the whole point, right? So today's topic is on MOVs. What is
military-owned vehicles?
Yes. Yeah, so we're talking about deuce and a quarters, or deuce and a halves.
Deuce and a halves.
We're talking about, of course, the traditional Humvee. We're talking about my favorite vehicle, the Jeep.
Which is the best of all of them.
It is, of course. Especially the old classic Jeep, Jeep Wrangler, or not Jeep Wrangler, it's probably Jeep when it was actually a Jeep.
Well,
in the
first
military.
off, it never was a Jeep in the military.
No, correct.
But
what was the actual correct term for that? Do you know what that was?
General purpose. In fact, I'm trying to remember the number when I was in, because we had the Vietnam era Jeeps, which were a little bit lower profile, oil-filled air filter.
Yep.
So you actually had to go through an oil bath.
Yep.
Little tiny little sewing machine motors in them. Great vehicles. Love those things.
I'm really happy.
Dangerous on the road.
Yeah.
Four-wheel fully independent suspension, because it could fold under you.
Yes.
And happen more than once.
I'm really glad that we ran with this joke for just a little bit longer than we should have. No. Okay. So what we were talking about today.
What is the purpose of an MOV in our discussion?
Yes. So an MOV, of course, stands for Metal Oxide Varistor. So what it does essentially is it acts as a surge protector.
So we're talking about surge protection.
We are talking about surge protection.
Took a while to get there.
Yeah, I know. Eventually we made it there, right? So we are talking about surge protection today. It is a topic that, as a company, we offer surge protection. We have a couple devices. We have some power strips, some pretty basic or straightforward power strips, and give you additional outlets in different situations, or wall taps and whatever else. But we also offer a couple other items as well. Our ASP603W, which I know today's not really meant to be a topic about product.
The product.
However, our ASP603W is kind of a neat one because it has that smart capabilities where you can remotely control 4 of the outlets on it. So come back this Friday where we'll be talking about the ASP603W.
We also do have the HDMI surge protector, but it is not an MOV-based surge protector.
What is that based on, Brent? Do you happen to know?
I do not.
Okay.
It was engineered by somebody substantially smarter than I am.
Right.
Within the IEEE 8300,
sure,
I think, spec, and it's 8,000 volts clamping. Now, it's not super high joules because you don't need high joules for ESD.
Correct.
What it does, however, deal with is the spikes. But that's not today's discussion. You got a much better one for today.
I do.
And I see you have some artwork you're going to do.
I do, yes. So
I'm looking forward to this because it's got to be better than your math.
Yeah. So one of the things that we have to understand about a metal oxide varistor or surge protector is that there's many different kinds. And pardon me, let me back up. There's many different kinds of surge protection. There's actually probably about 2 major ones. One is it's a relay assisted, I think is what it's called, RA. or RT, one of the two. I forget exactly what it's called, but essentially that one works different in that
there is math involved in this. I can see it already.
Yeah, exactly. So that one's different because the way that it reacts to the problem is it triggers a relay to essentially open or to close and then shunt all the power somewhere else.
Which may not be fast enough.
It may not be fast enough, but again, I didn't go into too much research on that particular style of surge protector, so I don't want to speak too much of it and say the wrong thing. But instead, an MOV uses a varistor as its medium to, or probably a varistor system in order to dump that extra energy or extra voltage somewhere else.
And it is the most common in our industry.
It is, yes. And so the idea for an MOV is that it's metal oxide, and a lot of it's based on a nickel. Let me make sure I get the right thing on here. It's a nickel-based solution inside of it. So, but before we get into that...
Is that a dry solution or a wet solution?
It's a dry solution. But before we get into that, what we do want to talk about first is what is a varistor. So, you know what a resistor is, correct?
Yes.
Okay, so a resistor resists voltage. Up, past a certain voltage, it resists it back down to a certain
I just thought it was
level.
life. Resist pretty much anything you want.
Well, in your marriages, yes. That's what you ran into. But no, with a variable resistor, and that's what that stands for, a varistor, V-A-R-I-S-T-O-R, it's a variable resistor. Now, there's different kinds of variable resistors. There's a pot, which is just basically simply a rotation of some, or a piece of equipment that changes the resistance based on its position. That's a variable resistor. It's variable. You can change it, right? Now, the difference, though, is that what an MOV is it's automatic, because it's based on the voltage that's currently running through the system. Will tell it how much of a resistance that it has, how much the resistor works based on that voltage. And
so I understand as voltage goes up, resistance increases?
Resistance decreases. So it's inversely proportional to an increase of voltage is a decrease in resistance. And so there's actually kind of an interesting thing. And what I'm going to do is I'm actually going to do this here. So hopefully everyone can see that. And I'm going to do this so that we are on the screen. Hey, everybody, there we go. Okay, so I probably shouldn't have drawn this first, because I should probably draw instead where an MOV is in a surge protection system, right? So if you'll hand me the eraser over there, I'm going to start from scratch. Did you get rid of my straight edge?
I'll bring it back.
Okay. So if I understood all the drawings correctly, and I believe I have, and so if I'm wrong about this, everyone, please let me know what the correct term, or how it's supposed to be done.
I'm going to claim you're wrong even without knowing.
Well, and I'm perfectly fine with that. So I'm going to get my drawings out here and make sure I have the correct symbol for this, because I want to draw it correctly. So the idea is, you've got your power coming in, and so we're going to call this, I believe we've got our hot and our neutral. So that comes in like so, and it goes over and it does some kind of work over here, right? It goes into some kind of piece of equipment over here. That's where it actually is doing a job, doing its work. What a MOV does is it gets added in line like this. Let's see if I do this correctly. Draw this box here, and then we get a piece that looks like this, goes across, and then looks like that. So this is put in line on these two lines here. It can also be put in between the hot and ground if you wanted it to, or the neutral and ground if you wanted it to as well. It just changes how it's going to be shunting all the excess energy that comes into it. So the way that it works is you have 120 volts coming in.
I'm seeing this now. I get it.
Do you see it? Yeah.
Yeah. So. Yeah. Got it. So as this increases, this reduces resistance and allows it to shunt it back out.
Right. So normally you've got 120 volts that goes across. Now, of course, it's AC power, and so that AC power is going back and forth, right? It's not directional. It's just going back and forth. So you've got 120 volts here. You've got 120 volts there. An MOV is non-directional, so that means it doesn't have polarity. It's bipolar, I think is the correct term. It's bipolar. It's two poles on. It's able to go in
serious anger issues.
It has the inability to control its anger issues, is what it comes down to. So the way that this works is that 120 volts means that the resistance. Let's see if I can draw the ohm. There you go. The resistance of
is futile.
Is, yeah, right. the resistance of an MOV is very high, right? It's a very high resistance to the electrons going through this system. This looks like an open connection. It looks like there's
right,
nothing
it's just not
there.
going through.
Right, it can't go through that. There's too much resistance. So instead, it continues on down here. Now, if this voltage increases up to, say, let's do 135 volts, right? The resistance of the MOV actually begins to decrease.
So it can bleed.
So it can bleed, exactly. In fact, bleeding is one of the things that they call this, is it actually bleeds. Even at 120 volts, there's actually a very nominal, or very...
It's always a little bit of bleed, just to make sure it's always awake.
Yeah, kind of. It's not even that it's awake, it's just a part of the system that it works, it's doing that. So essentially, the way that this works, again, is as the voltage increases, this resistance decreases until eventually it decreases to the point where it is infinite.
Just completely open.
Yeah. Did I get that right? Yep. Infinite resistance. Or no. It's not open anymore. It's actually a completely closed circuit. Now here's the thing. Electricity is looking for the path of least resistance, right?
And if it's got a shorter gate, it's leaving.
So if it's got a shorter gate, because it's got to do work over here,
yep.
It's lazy. It doesn't want to do work. It just wants to go to ground.
So
right?
effectively, I'm an MOV?
You're an MOV, yeah. So no, your electricity is what you are. You have to work in certain circumstances. However, at a certain point, given the opportunity, you're gonna crash and you know,
get in the hammock and go to ground.
Go to ground.
You know what? I'm liking this.
Right? Okay. So eventually, once this voltage gets up to a certain point, it's going to completely short out this connection here.
I see, and so that's gone.
Yeah, exactly. So it loses that connection to the thing that's doing work. Now, the great thing about that is that's essentially what's happening with an MOV in an actual system. So let's say you get a spike or a surge of some kind. What it's doing is it's taking that voltage and it's just dumping it directly into, actually, pardon me, it's the other direction. From the hot, it goes down into the neutral, which then back at your panel, it is where you get the ground connection. So that's essentially what an MOV is doing, right? It's taking that voltage and it's dumping it back onto the ground if it goes above a certain threshold.
As it drops back down, it starts to close back up?
Starts to close back up, yep, exactly. And so then you recreate the thing that's actually doing the work, and it's got, you know, the connection for all of that, right?
That's awesome. So hence the big advantage over a standard fuse system.
Yes. Yeah. So the fuse, and that's the thing with the fuse system. Fuses are a little bit different because they work on
it's one and done.
Well, it's one and done, but they're also based on amperage rather than voltage. So a fuse, the higher the amperage on a fuse, is when it starts burning up.
High current draw.
Exactly. A high current draw is when the fuse actually breaks on it. So you will actually see, in addition to an MOV, you will also see a fuse. And I'm trying to remember what the drawing is for a fuse.
Is it the gas fuse?
No, so that's actually another varistor. That's another type of varistor. So fuse, electrical symbol.
Oh, isn't that cute?
So a fuse.
Oh, it looks just like a fuse connector.
Yep, exactly. So you'll actually see a lot of times a fuse is also in parallel with these systems as well. So you'll see something doing the work down here, right? So you'll see an MOV as well as a fuse. So we have both a voltage
and a current protection system.
And a current protection, that's right. So
because this typically is caused by this going bad.
And actually, I did that wrong. It's actually not drawn like that.
It's drawn in line.
It's drawn, yeah, exactly. It's drawn in line like this.
Right. So this is because this could fail. This is because that could fail.
Right. Yeah.
Or
because
be too much.
Because the power coming in could be too much for it. So exactly that. So you can say, well, a lightning strike, or someone runs into a telephone pole, or something happens externally from the system, and that's usually what increases the voltage coming into the system, right? That's usually when you have problems there. That's where an MOV steps in and helps to protect the system from there. But if you have a problem on this side where the equipment is beginning to short out, let's say you've got a stray wire that begins to short out on it, or gets an arc,
pulls more current.
Exactly. If it begins to draw too much current, which I think is a, hang on.
That's the little a.
Is it the little a?
I believe it's I.
It's I. So if you get too much current, which you know the correct term for that is, or the correct number for that is I. If you get too much current, This actually steps in and kills itself, right? It sacrifices itself to protect the equipment because the equipment is beginning to draw too much power. We don't want to draw too much power to kill the equipment. We want it to kill this.
Overheat the wires and catch fire.
Catch fire, exactly. Now,
this is probably already dead at that point, or going.
It's going. It's pretty darn close to it. Now, if you have car audio is a really good example of this because with car audio, of course, we deal with that all the time, right? You get a 40 amp fuse for a 40 amp amplifier. You get a 100 amp fuse for a 40 and a 60 amp amplifier. You know, it's simple math for that. AC is a little bit different.
Again. Simple math.
I'm not going to do any math, but it's supposed to be simple math. See, here's the thing. When I am not on air,
are you going to claim you can do math?
Math is okay. When I'm on air, when I'm live on air, I'm too in the midst of doing everything else, and I can't do math correctly.
Okay, yeah. I'm not buying it, but okay.
Well, if you ask Jessie, she doesn't think I can do math at all, which I think in the history of the stuff that I've done for her math-wise, I think I've failed on all of that. So that's essentially what an MOV is doing. Now, the question is, how does it work?
I mean, how does it do what it does?
How does it do what it does?
Can I clean this?
Yeah, you can. Yeah, you can go and do it.
I got to have some purpose today,
yeah,
other than
exactly.
just chide you.
Yeah. So we know why it's put in there. It's put in there for the purpose of protecting the equipment that's actually connected to all this stuff. But the point is that we need to be able to make sure. That's one thing to know why it's there. It's one thing to know where it's at in the system. But it's, for me anyways, it's fun to understand why it works. And so that's where another part of this comes in. So I'm going to draw the insides of an MOV and what that actually looks like. So we'll go back over here.
You really are pushing your luck today for drawing.
I am. So let's see if I can do this right. So we have this here. And I'm doing this from memory. But essentially, what we've got is a pad here and a pad here. Now, internally, and we'll get a little bit in here as well, like that. Now, that one's actually a little big. We'll go ahead and chop that in half a little bit.
Are those amoebas?
Yeah, sure.
Chips. They're chocolate chips.
Yeah. We'll go with that.
Oh, you know what this looks like? An almond cookie. One of those Dutch almond cookies.
Yeah. Okay.
You know what I'm talking about with the sliced almonds in it?
Yep. So this is probably too regular for what this actually looks like. But essentially what's happening here is you have this ceramic outside, right? And ceramic is a wonderful, what's the word I'm looking
for?
It's a wonderful material, but it's a wonderful...
medium?
No.
Conductor?
No.
Insulator?
Insulator, thank you.
You were going in the right direction.
Yeah, exactly.
Later, yeah.
So it's a wonderful insulator because it actually protects all of the stuff that's happening.
And what's
here.
Florida based on? What's ceramic made of?
It's sand and silica. Yeah, exactly. So
yes, we know from grounding in Florida.
Yeah, exactly. So you have this ceramic that's on the outside. Now you say silica because that's the interesting thing, because inside of here, now these of course are the leads that go inside of it. So you've got this lead here and a lead here. Now I'm going to look at this in a DC application. So we're going to call this the positive lead, and we're going to call this the negative lead. Okay?
It's just a bad attitude.
Yeah, exactly. So this is the negative apple. It's just going to ruin everything for everybody else because it's just a negative.
One bad apple don't spoil the whole bunch, girl.
By the way, if what I'm talking about makes sense, let me know in the chat. If what I'm talking about does not make sense, also let me know in the chat. And if I am completely wrong,
let us know in the chat.
Which is definitely possible. Let me know in the chat.
And if you think I have any future in song and dance, let me know. Yeah. I don't think I do, but I'm not proud.
You know, Brent, look, they have that new show coming out on
How to Be a Loser?
Well, no, they're giving people second chances at being musical, stars of some kind.
No.
So no.
Yeah,
okay.
I don't even want to hear myself sing.
All right. So your negative or your positive and your negative lead, you have this ceramic coating, and that's all of this here, all in this area like that, right? Inside of here, there's a substrate. You like that word, substrate?
Yes, I see you're using your syllables today.
Trying to. And in between all of this here is a silica-based substrate. And so what this is doing...
Now, is this a soft porous material? Is this a hard material?
This is a hard material.
Okay.
So what happens with the metal oxide varistor is inside of here you have the silica substrate, but you also have a nickel chip system built in, not nickel chip, but basically it's a nickel, what's it called? Nickel iron, I think is what it is.
So that's those little chocolate chip
blue
looking
guys.
things?
Yep, that's the little blue guys. Now, what happens is you do a lot of quantum mechanics, literally quantum mechanics, because you have the electron that's coming in from the negative side.
Yes.
And it wants to go over to this side.
Right.
Okay. So what's actually happened is the electron doesn't really want to go over there because
it's drawn.
It's drawn because it really just wants to keep going down that connection somewhere else. However, as the voltage increases, the pressure, which is what voltage is, right? Well, it's not really what it is, but it's the idea behind it. The pressure is built up, and essentially it begins to force it to jump from the lead on this side over to the nickel inside of this substrate, this ceramic substrate.
So just by pure pressure, it's now making the leap to those that otherwise it would ignore.
Exactly. And so then it makes its jump across. Now, what's interesting about this is that what these are doing inside of here is these are creating a diode effect. So if you had one of these pulled out, if you just pulled out one of these little weird things, what you'd find is that you actually create an almost diode effect. And so it's forcing the electrons to go in one direction, right? So by putting them into this substrate like this, you actually create a bunch of different, let's see, positive, negative, positive, negative, positive, negative, all these different directions for positive and negative. So you create all these directions in all these different directions, right? And it's a 3D environment inside of there, and all of these different directions is where you get the positive and negative. So that's what actually is creating this system to basically lock out the electrons from passing across, because it doesn't...
There just has to be a bunch of them enough to jump over it.
Exactly. So what happens is the voltage increases and it begins to change the way that these are pointing, right? You wind up instead, you got a negative here, maybe you have a positive here in this first spot, and I know that's kind of hard to see what I drew there, but you have a positive here and a negative here, and then let's say you have a positive over on this side and a negative here. When the voltage increases, it begins to rotate the polarity of these guys inside, so you actually get a path straight across. And so as the voltage increases, it begins to line it all up. Now, that's what's happening inside of it. So there's something else when it comes to surge protection, especially MOVs. Lifespan.
Well, yes, because every time you do this, you're wearing out. Each time you force this thing to happen, it's going to cycle less and less. It's kind of like running your motor without oil.
Yeah. So basically, those granules inside of there, what's happening is every time. That's exactly right. So Randall looked at it. Back-to-back diodes which don't conduct until reverse junction breakover voltage. You you found the Wikipedia article. No, but you are correct. That's exactly right. That's actually where I found this. So essentially what's happening is that once you get to that breakover, so think of an LED, right? So an LED is just a light emitting diode, right? It's just a diode. Now in a diode, it only allows electricity to pass through in one direction, right? That's
the whole purpose of a diode. It's a protection device typically.
Exactly. So what happens then is, let's say you take a diode and you plug it into something reverse polarity, right? So if it's a low enough voltage and a low enough current, it's not going to do anything. It's going to do its job. It's going to stop that current until eventually you reach a certain level of voltage and current that it now hits a certain point where it says, I don't really care, and it just passes over that diode anyways. It just passes straight through it. That's that breakover voltage that Randall's talking about in the chat. So that's essentially is what's happening here. You get up to a certain voltage, that breakover. It's like you're looking at the waves on the levees in Louisiana.
Yeah,
right?
they finally get tall enough that they just go right over.
They go right over top of it. That's exactly right. And so, but here's just like in Louisiana, back with Hurricane Katrina. When that finally happens, sure, the levees maybe 1 wave, 2 waves, no problem, everything's okay, and they're rather small and whatnot, no problems. But it happens over and over and over again. You get bigger and bigger waves, and then eventually the levee completely collapses, and it just creates an entire inrush of power. And that's essentially what's happening here with these.
So do these die, or do they just quit reverting back to their multi-directional?
Both. So these are based on a rating called Joule, of course. Now, a Joule is a bunch of math, and I'm not going to get into it.
What you get your wife when you get married.
But it's the, yeah, sure. But a Joule is the Joule, not a Jewel.
Like Jules Verne.
Yes?
Yes.
Yes. Okay. References that I don't know. Anyways.
Oh.
I'm sure
Back to the Future? Part 3, when he named his kids Jules and Verne.
Oh, wait a minute.
Doc Brown named his kids Jules and Verne.
Yeah. Well, he named
the writer Jules Verne. From Earth to the Moon.
See, I always thought he named his kid Jules because of the guy who discovered it, Joule. I forget what his name is, but
Jules Verne, science fiction writer, turn of the century.
Yeah, no.
The old century.
Yeah, no. Lost me on that one.
Voyage to the 20,000 Leagues Under the Sea.
Okay, that I know. Yeah, that I know. See, I know the titles anyways. I just don't know whoever wrote it, and I haven't read it either.
Nowadays.
I haven't read it either, so I mean there is that. I did see the classic one where the classic movie of 20,000 Leagues Under the Sea
with the giant octopus.
Yeah, exactly.
Okay, so back to
what we're
this.
Talking about here, yeah.
So as this continues to happen, the elasticity of these starts to diminish, so they do not return to their normal protective state, and they just kind of pass until they die?
Yes. So what will happen is eventually you run out of the ability for it to protect at its peak protection, right? When it's brand new, it's peak protection. 25.
Like when when your elastic wears out on your underwear.
Sure. Yeah. 2,500 Joule, 3,000 Joule, whatever it may be. When it first starts, it begins to decrease the amount of power that it's able to take a hit and keep going.
Is there any way to monitor that?
Well, there is. So what you can do is you can actually put a volt-ohm meter, put it on resistance, and you can read between the two leads. Now, in most cases, you won't be able to read a whole lot, but there's usually the manufacturers of the MOV will give you in their diagrams and a way to actually read it and test it.
But you really can't do that in the field.
Ooh. No wiki was taught. This is Randall. He's saying no Wikipedia was taught this by a retired NASA engineer 40 years ago. MOVs are expensive. Were expensive. They're getting much cheaper nowadays.
That could change tomorrow in China.
Don't say that, because this is already happening. I just read a report that said that we're getting past the problem of the chip shortage, and now we're running into passive electronic shortages.
That's the least of our worries.
So
if you haven't seen the news. They are now shutting the factories down 3 to 4 days a week for power.
Yeah, power issues are an entirely
power
different
issues.
Problem. But no, with the passive electronic devices, so things like an MOV or a cap or a resistor or something else. We're back to a demand for those devices now.
Because the parts they need for that are also going into the chips.
Right, exactly. So we're running into all sorts of problems.
Guess who didn't turn their phone off today?
You owe me a case of beer. It's your turn. All right, so
and what do I normally before we broadcast? Normally say, "Hey, did you turn your phone off?"
Turn it off.
Sorry.
All right, so Randall, that's brilliant information. You are correct on that.
And lucky you.
He's saying so if you're using DC, a single reverse diode is a cheap insurance. And you're right. It's just to make sure
Which is pretty much in every 12-volt device, they'll diode protect them.
Yep.
And if it's a high enough current, the diode will blow before, but it will absorb a lot.
Yeah, correct. So with an MOV, Randall, you know your stuff very well, because that's literally what you said was what's on the Wikipedia page. I actually have it copied in my notes. So that's why I was going with that. So you did. No, that's brilliant. It's really good information to have to understand how it works and why it works, because then you can apply that into what's happening out in the wild, and also it makes you understand why you need to protect things certain ways. So what we were talking about before, where you need an MOV to protect from the outside.
Right.
Yet you need a fuse to protect from the inside.
From the hardware side.
Right, yeah, exactly. So you have something usually you have something in the middle that catches both of them from both directions, right?
And the inside concerns me because that's that can cause fires. This concerns me because it burns out everything downstream.
Yeah, which can then create a short somewhere else, which then causes the other problem, which then causes, So, yeah, do yourself a favor, put in an MOV of some kind or a surge protector of some kind, some kind of device with that into your system to help protect what's there. But essentially, this is how it works. This is what's happening inside of those MOVs. It's actually, when you look at an MOV on the board itself, and I'll switch back over here. When you're looking at an MOV on a board, it looks almost like a small. You and those pads.
I like to be clean.
So on the board itself, and we'll use green for PCB. So on the board itself,
that's only fair.
Yeah, exactly. So you get what looks like 2 leads coming off of it, and then a disc, right? One side will come in, and usually it looks like that, and then on the opposite side, it looks like the reverse. It'll come up and then shoot across the other direction. And it's not very thick. Usually it's pretty thin. You got the wires coming up here.
Yeah, like a dime size thing.
Yeah, roughly. And so you get something that looks kind of like that on one side. And so when you're looking at it side on, that's kind of what it looks like there. It looks about the size of a dime or a nickel, somewhere in between, maybe even a penny. But it's covered in usually a plastic or a rubber to kind of help protect it. But so underneath of that is a ceramic. Should my statement
be an MOV for your thoughts now instead of a penny?
An MOV for your thoughts. Mark Sybil's asking, Randall, what alternative can you use for AC? I'm kind of curious about that as well. Are you talking about other than an MOV, or are you talking about the diode? I'm kind of curious to see what you have to say about that. So when you see these on the board itself, you may look at those and think that, well, that also looks like a capacitor, because there are capacitors that look like that.
Or it's really old technology. Why is there just old technology sitting on my circuit board?
Yeah, exactly.
Because everything's chip driven now.
Yeah. So, but that's purely because this is able to handle the power for that. MOV or gas discharge device is best choice for AC line voltage. That's exactly right.
The gas discharge device, but it's typically you don't see that near as much as you do this traditional MOV.
So actually, one of the interesting things that you see, yeah, go ahead. So one of the interesting things that you see with
I gotta have a purpose.
A varistor or a gas discharge device. Regular air that we breathe every day is a varistor, right? It's not a metal oxide varistor, but it's a varistor.
Like how lightning works.
It's how lightning works. So at a certain point, the voltage increases to a certain magnitude or the differential in voltage increases to a certain point where it finally breaks through the resistance of the air and it arcs across whatever it is to the other side where it wants to go, usually the ground. And that's where you get that connection. So the air that we breathe is actually a varistor of some kind. It's a variable resistor based on the resistance of the air.
Okay, that just brought another song to my mind.
Uh-oh.
Sometimes all I need is the air that I breathe.
Uh-huh. Yeah, no, I don't know that one. Yeah, I don't know that one. You got another one? You want to keep going?
No,
I'll tell you again, I don't know that one.
Yeah, you're just making me feel old. Granted, I'm better looking and I have more hair, but I'm still feeling old.
Randall, I really appreciate your insight on this. It's very helpful to have somebody who has that background with it.
And a second set of words.
And a second set of words. And this is something that what I do here as tech support and also product development, I'm not the guy with the engineering degree. For the electrical engineering degree, I just try to make the most sense of it as I possibly can, and I like to bring as much of that sense as I possibly can out to people who are watching this, and give good information out.
And it certainly helps when talking with your customers is to understand what and why, because that justifies the cost.
Yeah, exactly. So when you look at how to use surge protection inside of your systems, right? That's something that we need to consider as well, because it's not as simple as just saying, oh, well, let's just put in this surge protector. You kind of have to consider the Joule rating, how much protection it actually gives you, and the type of resistance or type of surge protection that it has to offer. And you have to kind of design that into your setups to make sure that you're protecting your investment, right? Or you're protecting the investment of your clients.
As an integrator, you need to be working with the electrician to make sure that absolute polarity has been followed. Because look, if they get the wires backward on an outlet, the light still turns on.
Yeah.
Is there a good ground outside?
Yep.
And as we know, living in Florida, which is in fact a silica-based substrate, I mean, when we hammer ITT copper rod into the ground, we're hammering into an isolator.
Yes, exactly. So
an insulator.
We're hoping to get down to the water.
Yeah, we need 100 foot of copper rod to matter.
Yeah, the groundwater is our ground, is basically what we use. So and that's different than say like
North New York and
yeah,
Virginia
exactly.
and places where there's mountains and granite. And
like for instance,
clay.
we use on our pastures with our horses, we use a electric fencing with that, and the idea with electric fence is that you've got a device that sends a couple
pulse.
thousand volts of a pulse out, and what it's supposed to do is it's not supposed to go anywhere unless something touches it, and then that becomes the conduit to the ground. But then you're supposed to pound a ground stake into the ground, and that usually works with just a simple 2 or 3 foot stake in the ground here in Florida because it's such a high voltage.
Low current.
Yes.
High voltage.
It's just enough to shock them and scare them and get them away from it.
And how many times have you touched that?
Twice.
That you're willing to admit?
Yeah. No, twice.
Okay.
Once when I was a kid, and I had no idea what was going on. I had my rubber boots on, so it didn't hurt as bad as it could have, and it never really hurts.
It doesn't hurt. It just lets you know this is a bad idea.
Yeah, exactly. It's the current that's going to hurt you. Second time was when I had a round pin panel that I was trying to move from one area into another, and everything was working fine until I lost balance with it, and it rolled over onto the electric fence, and like an idiot, I held onto it.
Are you telling me that you were never drunk with your buddies and one of them dared you to urinate on that?
No.
We're going to go drinking.
Yeah, exactly.
We're going to go drinking together.
Randall says, doing a good job. Thank you so much. Really appreciate that.
And it's all him today, so.
Well, it's all me every day, let's be honest. No, I'm kidding.
I'm just going to go over here and sit and be sad and maybe cry.
The only reason you're here is to be the comedy,
old guy?
the comic relief, yeah. He says he takes tech support calls from Florida. It's almost always an extender that decided to get in front of a lightning bolt. And he says use house lightning arresters.
By the way, extenders can act as an excellent fuse.
Yes, they can. Yes, they can. And most times they do act as an excellent fuse and an excellent ground. Again, that's one of those things that we look at as HDMI specialists is HDMI is a fantastic ground. I mean, it's got how many different ground connections inside of it?
Let's see, you've got 4 TMDS feeds that all have their own XLR ground.
Right.
Overall shields, an overall shield on the jacket.
Right.
And then, of course, it's tied to the same ground on the back of your gear as your coax, your Ethernet, and your serial.
Well, and don't forget it's got the DDC line in there that's also has its own ground and
an
all
overall
of that.
shield,
so,
yeah.
But yeah, so anyways.
There's a lot going on in there for grounding.
Oh, it's brilliant for that purpose. But yes, an extender in that case. Now he's saying use whole house lightning arresters.
Yes.
So that's one thing that during my research I ran across those and found those and found them very interesting. And something that I wanted to do more research on. So Randall, let me know in the comments or in the chat.
Well, now, and see, here's the thing. I have that on my house.
Okay.
I have that on the boss's house.
Real quick, Randall, let me know in the chat what brand you use and also what it's capable of. I'm kind of curious about that.
Here's what they don't do for you, because those are essential for protecting the house.
Right.
But in all honesty, the vast majority of what we see in our world doesn't come in over the AC lines.
Correct.
It comes in from the cable company or the phone company that you're getting your networking from.
Yep. And
that is not covered by the whole house protection.
Yes.
That's where our issues come from. Now, grounding is very important.
Yes.
And when I was up until the 90s, in Florida, a 6-foot horizontal ground was considered acceptable.
Yeah.
Now think about that a minute, just 6 foot horizontal.
Yep.
We're talking inches below the surface, not vertical.
Yeah, exactly. Yeah.
And even now, if you see a 10-foot rod, you're doing good.
Going into the ground,
and 10
right?
foot's not enough
Going straight
to
into it. Mark Silver saying, if it wasn't for age and experience, we would all be idiots. We'd all be young and stupid.
I'm not going to go much for.
Now listen,
I'm still on the idiot side.
I will give you experience and age.
That doesn't make me stop doing the same dumb stuff.
How many times have you stepped in that
pile of fecal matter?
Yep, exactly.
Many times, and often barefooted.
Yeah, multiple times, and did it again. So
I show up here every Wednesday with you, don't I?
No, there is that part of it. So when you have the MOV in place, and one of the things to consider as well is the life expectancy of those MOVs.
Well, and that's kind of one of the things I asked about earlier.
Yeah.
Is there currently a way to track the life cycle, or how much activity I have left, how much protection I have left in my MOV. Is there any product I can buy today? And this literally is not a leading question.
Yeah, yeah.
I know it sounds like one, but can I go buy something off the shelf right now that tells me how much life I have in my MOVs?
Not really. The best way to really do that is with a multimeter. And again, you need to find out the manufacturer of the MOV itself and test it there.
This is truly not a leading question.
Yeah.
I'm curious.
Yeah.
Do you have to open the unit up and test at the MOV?
Yes.
So then basically the answer is no.
Yeah, correct. Yeah. Because opening it, of course, is going to void the warranty and everything else.
Well, and then you got to take it out of the rack. And
yeah. So, but here's the thing: when it comes to devices that do the surge protection, the way that the way that the MOV is going to do it is going to sacrifice itself, right? So the first thing that it does is it takes the hit and it begins to shunt that power or that voltage down to the neutral line, which then eventually makes it over the ground.
Right. But as I'm understanding this, would you give me an overhead? Whatever the rating is, the first couple of times I take the hit, I'm at that rating.
Yep.
And I'm fully protected at that rating.
Yep.
But over time, my ability to take the high voltage surges diminishes.
Yes.
So eventually, it's going to take very little to shut my system down.
Yes, that's right. So at a certain point, as you get to this here, at the highest point, you can take a hit, and you can still kind of keep going, right? Until eventually you get another hit, and then another hit, and then another hit, and then another hit, and you can't come back from that, right? So when you get to a certain point, as you're talking about, you get down to a certain point where you now have crossed the threshold of coming back.
The system can still function, there's just very little protection, or does it fail at that point?
Both. So what'll happen is that if you get down to a certain point, even a small surge event of some kind can come in and knock it out, right? And if it does finally knock it out, what's going to happen is it is going to short out that MOV entirely, and now it's become a short. And eventually what will happen at that point is that if it does short out like that, it may even blow a breaker inside of your house.
Okay.
And so then at that point, then you really know, okay, well, something's happened. I got to take that piece out. And usually there's like a little protect light on the little power strips and whatnot.
Gone.
Yeah, that it's gone.
But that doesn't tell you the life and how much time you have left on it. There's no fuel gauge.
What are your thoughts on dual power line conditioning?
Yes. But
explain that.
Okay, when you're looking at dual power line, you're not just, typically when you have it, take a typical conditioner.
Sure.
Now, a typical conditioner is not $100, it's not $200, you're thousands of dollars.
Sure, yeah.
But you're effectively treating the AC as a single. With dual line conditioning, you're separating, you've got typically not just that, you've also got powered line regeneration. So you're going in the conditioning, you're taking out all noise, you're checking for grounding, and then you're going to regenerate it at 120 or 1.
Right.
So the advantage is, in theory, you have a fixed, regardless of the change coming in or out.
Right.
The output's always the same with the regenerator. With dual line conditioning, and the costs are high.
Yep.
And there's some very good stuff out there.
Yeah.
That does that. I mean, big giant toroids, and in the past, I assume it hasn't changed.
Sure.
The only way to really handle this is with a big giant toroid.
Because
it's a lot of copper, a lot of weight, right? It controls it.
It's basically a momentum effect, almost basically, right? When you get the big toroid in there, you get the electric resistance that comes into it. I have no clue how they work. I mean, that's the way that I see it in my head.
It's the giant copper donut.
Yeah, the big.
No clue how they work. All I know is they work. We used to have a product called the ESO.
Yes.
The Ethereal Super Outlet.
Yes.
Which fit into a deep 2-gang box, and it was a giant toroid with MOVs on it. And it eliminated a ton of noise on the AC lines.
Yep.
Plus gave you, that's a autoformer. But that's not the ESO1.
No, it's not.
ESO1 was the big giant aluminum plate outlet.
Yep.
Thing was awesome. It would absolutely improve the quality of your video, because video and audio cannot always separate noise on the line from what is signal.
Right. Well, especially back in the analog days, but even still on digital.
Doesn't make that any better.
Yeah. Well, in digital, actually, in fact, could be worse, because if you get like an odd, a 1 turns into a 0 or something else. Yeah, exactly.
Be read as data. The ESO1 is something I would love to see back in production, and currently it's not.
Yeah.
We're going to put that on your list of things to figure out, since you're in charge of power now.
Sure. Yeah. We'll figure that out.
But
Randall,
yes, anything you can do to protect yourself, good grounding.
Yep.
And we've talked about grounding on the show. We've had our electrician Rob in.
Yep.
By the way, he's back to work on the 11th.
Oh, good. Okay, good.
Our electrician had a substantial motorcycle accident.
Yes, he did. Yeah, so I'm excited to hear that he's going to be back in the office.
Super light duty, whatever that means.
Well, just
don't buy a pickup truck labeled that.
yeah, don't. Yeah.
I got a super light duty pickup truck.
So you got a Civic?
No, that's probably not super light. That's probably reasonably well
Reasonably, yeah, exactly. So Randall's saying, he says he hasn't installed in the field for a long time, but any brand names such as Leviton or Siemens are excellent choices. He says $200 is a lot cheaper than replacing all of your gear.
Yes, it is.
Yeah. Yeah, honestly, and that's something that even the cost of having the electrician come out and install something like that is still worth it because...
Well, you protect the whole house.
Yeah, exactly. So it's not just your AV equipment. You're protecting your refrigerator, all your appliances, your AC system, basically anything that's being powered by that connection is protected.
Now,
at
one of the
point.
things you and I have talked about in the past in one of our tech tips is house grounding.
Yeah.
And this is all assuming that your house ground is proper. If your house if you lose the ground to the power pole,
yes,
your only ground can become what's in your house.
Yes.
So house grounding is super critical.
Yep.
And MOVs can help protect you there as well because it can help shut it off if you have so protection's critical.
Yeah. Honestly, when it comes to, we really need to talk about surge protection from start to finish and what is involved with that, right? So we talked about an MOV, we've talked about grounding inside the house, but we really need to apply that to a situation, right? So one of the things that we need to look at is when you have a house that you're stepping into as either a home buyer yourself, as an installer for the low voltage equipment, or even as an electrician, you really need to work together with all of the trades and everything else and make sure that the house itself, first and foremost, is wired and grounded correctly.
Now, that is starting to improve. I can say at least in Ormond Beach.
Yes.
When we got the CO for the beach house, the inspector went to every single outlet.
Yes.
To check every outlet for proper grounding.
Yep.
Not just one or two, which I saw a lot in the 90s.
Yeah. Yeah. Well,
so inspectors are doing a better job. Electricians, I can't speak for the world.
Yeah.
I can only speak for the electricians I work with because they work with you and I and know what we expect.
Yes.
We don't run into a lot of those issues.
Yeah.
But
find if you're an installer or you're a dealer of our products or anything like that, and you're working with builders, find out the electrician that the builder works with most commonly. And in fact, you probably already know them because you deal with them every day. However, it's worth it to take them out to dinner, get to know them a little bit, make that rapport with them, because that's something that as an integrator, you're going to need to rely on them in order to make sure that your equipment is powered correctly and protected correctly. Because you can put a massive MOV with all the Joule ratings, possible on your system, get a giant toroid, system in there for making sure that it's beautiful power and everything else. That's great. But unless you're going out there and running your own ground from that equipment to a pole outside in the dirt.
And there could be issues with you doing that by code or
exactly.
Or the electrician getting a little bit upset.
And well, this is satire. You wouldn't be doing this is basically what it comes down to. But the point is that you won't be doing this on your own without them. And so without them, no matter what you put in there, it doesn't matter if you're buying $20,000 worth of surge protection and filtration. It's not going to work correctly if the house itself isn't wired and grounded correctly. That's really what it comes down to, right?
Well, we take calls all the time where we have them, a problem between the AVR and the projector. We have them run our flat panel. We have them run an extension cord from the AVR location to that other display device, and the problems disappear.
Right.
Because they're ground related.
Yeah.
Now it could just simply be a problem where they don't have the screw tight enough on the ground wire.
Yep.
It could be miswired, or it could be completely disconnected.
Yeah, you could be on a completely different panel that is creating a differential in voltage on the ground
on either
plane.
side of the panel.
Yeah, exactly. So anyways, we're up to about 50 minutes now for today's episode, so I think we need to go ahead and wrap things up. So right now,
so MOVs are your buddy?
MOVs are your buddy, and honestly, they're a good thing. Richard Gray has a nice whole home.
Yeah,
Richard Gray. It's $30,000 for that piece.
Well, but he's also got some less expensive stuff. But his stuff, there are certainly a lot of things in our industry that you and I look at and laugh. As questionable products.
Yeah.
The Richard Gray products, in my opinion, are real.
Yeah.
They're not questionable products.
And I would agree with you on that as well.
$2,500 power cord. That's a questionable product.
Yeah. Anyways.
No, unless you're buying it from me, I'll
no, of course it's real, right?
It's your $2,500 power cord.
All right, everybody. Thank you for checking in with us today. As always, if you have questions about whatever it's been that we've talked about on today's episode, you can, of course, reach out to us on our tech support line. 386-492-8584 is the contact number for us here. You can also email me at adam.rogers@metraav, or you can email you.
Brent.mccall@metraav. And we actually hope to soon have a panel
something up there.
It seems that our 8K set is parts back order, and based on what we've seen, I'm guessing it'll be next summer.
We're gonna have to put something up there to get something back in place.
Definitely miss having.
Yeah, I'm ready to get rid of this.
Yeah, and
it's become a catch-all, unfortunately.
Yes, it has.
So, everybody, thank you as always for checking in with us. If you have, like I said, any questions, feel free to reach out to us on our tech support line, or leave us a comment down in the comment section down below. Give us a like and a share and a subscribe if you haven't subscribed yet, and hit that bell notification to let you know whenever we do go live. You can, of course, find us on Facebook, Twitter, Instagram. We haven't done TikTok yet. I'm trying to convince you to do that. We're going to get you to do the dance moves and stuff.
If you point the camera at me, you know I'll do it. Pride, I got no pride.
Dance, monkey. So you can find us on basically any social media. You can also reach out to your sales rep or your distributor to find out availability and pricing of any of our products that we talk about.
May I have money, please, sir?
Yeah, sure. So from there, everyone, we'll see you next Friday, or this coming Friday?
Well, you won't see me.
Yeah, you'll be gone.
I'm taking the day off. I'm going to Delray Beach and eat. It's food tour weekend.
And you didn't invite me?
You know, and not as a joke. Not as a joke. One weekend, if your wife will let you out, and I know that you have, being family, and you are legitimately a family man.
Sure. Yeah.
I would love to take you down and feed you Thai on Friday night, and do a food tour on Saturday.
Ooh. Well, I'll have to figure something out.
You know, it's just.
Maybe we can meet up with some of the viewers and some of the dealers and stuff, right? Yeah, exactly.
Yeah, it's Delray Beach.
Yeah.
And he's opened up, our CFO's #1 son does food tours.
Oh, okay.
Has opened up one in Lauderdale now.
Oh, wonderful. Okay.
I haven't done that one yet. That's coming up soon.
We'll have to look at it. So, all right, everybody. Thanks for checking out today's episode. We'll see you on Friday, where we're going to talk about the ASP603W.
I'll see you on Friday.
Yeah, I'll see you on Friday. Come back next week, where we're going to talk about something else. I have no idea what we're talking about next week.
You planned this. We had a schedule.
Hang on, I'll tell you exactly what we're going to talk about next Friday, or next.
Just so
next
you know,
Wednesday.
I will be in the little car, top down, sun shining, for that 3.5-hour drive south on Friday afternoon.
I figured you would be. And why is this not responding?
We don't know what we're doing next week.
Yeah, not yet.
But we will be doing.
We'll be doing something.
Call Morgan, she'll know. Because we sent her a whole list.
Yes, we did. Yeah, it's freaking out. Anyways, so check out for us next Wednesday, where we'll again go live at 3 p.m. Eastern time, and of course come back Friday.
To see him on the ASP603.
Yep, and we'll go from there.
I'm Brent.
I'm Adam.
We're out of here. See you on Friday.
Yeah. Don't forget, reboot early.
Reboot often.
Don't get your wires too short.
Turn off CEC.
And call tech support. Bye, everybody.
55 minutes.